Alright, good morning everybody. Even if it's not particularly morning where you are, it is morning here. It is 6:50. I just had to look at the clock. But yeah, so what are we doing today? I want to continue work on our platform layers. And that means that today we're doing input, particularly keyboard input. I'm not worried about mouse input right now. But I also, between episodes, I made a to-do list because I found a bunch of bugs with what we did last time. One of them is particularly bad. So right away, I need to fix this. This is bad, right? We're not actually handling the quit message. So let's actually handle that because, and also I have this project here for reference, so if I can do like, you know, I can look at this diff that I did earlier. Basically I just duplicated the project to start, you know, because I do these, I figure out how to do what I'm going to do first in a separate project, and then I record this for you after I've already mostly figured it out. So yeah, let's just go into, yeah, X11 perhaps? No, this should be Win32, and then right here in our message loop, this is what we're looking for, not that. Yank all of that and put it right there, basically. Alright, cool. So, we don't need that. Let's see here. So, I guess, actually, before we add this code in here, I want to quickly show you exactly what the issue is. So if we run for our Win32 platform and we let it run here, you can see our message loop is happening, right? You can see it happening. But whenever we close the program, it actually just keeps going forever and it doesn't stop, which means if you ran this executable and you haven't restarted your computer yet, it might still be running. So yeah, go in your task manager and shut that down. But here we go. So this is the thing, right? We need to add this in order to actually deal with this. Just like this. So we have the WM close message, which is the message that happens whenever Windows decides, hey, it's time to actually close the window here. So let's see. This should be fun. Let's try this. Let's see what this does. Because I think what we're gonna get now, yep, we're gonna get a confirmation prompt and then it's gonna close the window. Perfect. All right. And now, oh, yep, internal state dot is running equals 0. This is the most, well, not the most important part, but a pretty important part, because if you recall, in our main.c, our game loop basically just keeps running while the engine is running. So, and is running returns that internal state is running variable. So we kind of need to turn that off if we want the engine to stop running. Makes sense. Let's just, there we go. And now, just update this for my particular code style. Just like that, and that looks pretty good. Okay, so next item today on the to-do list is, and I'm actually going to remove these as I get them done. So we need to define Win32 lean and mean. Why we need to define this, I don't remember. But we're gonna define it because I know it's good. Basically, it just like slims down the Windows API to its bare necessities, I believe, is what it's supposed to do. So we're gonna do that. Lean and mean. Did I do that right? Win32, lean and mean. I think I did that right. Alright, so the next thing is we forgot to set the OpenGL version. So yeah, right here, basically we just never actually set up the OpenGL version, which is pretty bad. Alright, so we're going to do version 4.6, so that's the major version is 4, the minor version is 6. And then if we go back in here, we can remove that. Ensure that Win32 and X11 windows both start with the same frame buffer size. Yes. So if we open our X11 window, you can see, I believe this is like 854 by 480, which is like Minecraft resolution. And then if we were to run our Win32 application, this is going to be something different, I'm pretty sure. Yeah. So this is, I believe this is 1280 by 720 or something. But yeah. So let's fix this. Basically, in order to do this, we're going to need to go into platform.h and then change the actual API for creating a window. So we're going to do unsigned int width, unsigned int height. You know, I really wish you could just do this in C, like just say unsigned int once, but apparently you can't do that, so whatever. That's annoying. Anyway, so now we're going to have some conflicting shit going on here, because pstart is defined differently in different parts of the code. So if we go into here and then we go to start, we basically just need to redefine this like that. And let's see, wherever we see this use default thing right here, these second two, this should be width and this should be height, right? So that's basically how you tell the window to start at a certain size. And then what else do we need to do? Basically, we already have these members here. So basically in the start function, at the very end of the start function, wherever we set is running, I'm also going to set internal state dot width equals width, and then internal state dot height equals height. Just like that. Perfect. Great. And next up, I mean, we're going to have to do the same thing for X11. So quite possibly, I want to do that here real quick. Let's just do this real quick, because I think, oh yeah, too few arguments to pstart. So in our main.c, we actually do have to specify the width and height now. So I'm going to just do, let's just do 640 by 480, because that's one that we haven't used yet. That's kind of the key thing here, is I just want to make sure that it's actually working. So we'll change it to 854 by 480 probably later, but for now I just want to make sure it's working, and it appears to be working. Perfect. And then I need to disable that message box. That's annoying. Where is that? Yeah, let's just not do that. Oops. So, okay. Now we should be able to just close this without the message box, right? Can we do that? Yes, we can. Bob the Builder. All right. Coffee time. Coffee time. Time to think and drink, as they say. I don't know that anyone says that, but I say it now. Alright, so let's see. What is next? What is next? Probably just doing the same thing but in X11. That's probably the next step here. Let me actually gather my thoughts real quick. Alright, we're back. So the next thing after that, since we've done this, right? Or actually, no, wait, no, we haven't done this, because if I run the X11 window, that's definitely not 640 by 40. So that's the next thing we need to do, is change x11.c, and this needs to take an unsigned int width, unsigned int height, and maybe that might be it. We basically just need to set. Let me just find everywhere we mentioned width here. Yeah, this GWA thing, we actually don't need this anymore because I'm going to be storing the width inside of just this variable, so we don't actually have to get it now. We can just say width and height right there. And then right here, I guess that's it. The only thing that's left is we want to set internal state dot oh gosh, okay, height equals height and width equals width, just like that. That's gonna be great, I would say. The only issue now is that those are not actually members of this struct, so let's fix that. Alright, here we go. However, we still have the wrong window size because, yeah, we don't want these variables up here, these window width and window height variables. I'm actually just going to delete those, and then width and height. Wait, what? Okay. There we go. All right, so now our windows, they always start at the same size. However, they don't start in the same position, and that's not necessarily as big of a problem. So I'm gonna wait on that to fix that. However, git add, git commit, and basically, what have we done so far, right? Let's see. Okay, so we handled that message. We handled the close message. We set the OpenGL version. Let me actually just do this. Term get. All right, cool. And then term get commit. Let's just do added Win32 lean and mean, handled WM close event, set OpenGL version to 4.6 in Win32 mode, I guess. Okay, and then, yes. So the frame buffer is now the same size on both X11 and Win32. And I think that's it. That's all we've done so far. Alright, so there's that. And if we do git status, yeah, we just need to push. So do I have git push in here? Hey, there we go. Perfect. Okay, well maybe that doesn't work. Alright, so with that code pushed to GitHub, we can actually remove all of that stuff from this file. And let's see, so handle loopback message events, that's for networking, we'll do that later. Let's see, create an event system to listen to the platform layer. Yes, this is important. Again, we'll do that later. I kind of want to draw a triangle, but I don't know how we're doing on time right now. We are doing, oh, perfectly well. We can definitely do a triangle here. So the triangle part, this is actually pretty nice because the only thing we have to do is actually in main.c, we need to write some OpenGL code, which is pretty sick. So the references for this, I'm just going to use learnopengl.com because it's just tried and true and everyone uses it. So we're going to go to their hello triangle. We're just going to do a non-element based drawing, non-indexed drawing. So if you know what that means, then basically we're drawing every triangle as a group of 3 vertices instead of optimizing the mesh where sometimes you can share vertices between triangles. It's like every triangle has its own set of vertices, which is kind of unoptimized as you get to bigger meshes, but for now this will be just fine. So the first thing we need to do is actually define our shaders, and they're going to be right here. So let's just do this here. Again, this is not a tutorial. I guess I should probably say that at the beginning of every video. This is kind of just me live coding. If someone learns something from it, then cool. But yeah, it's definitely not particularly a tutorial. It's not. So, okay. Next in here, they load GLAD, and then after they load GLAD, they're basically, I'm just gonna put all of this shader code into a helper function. So all of this here, this is basically just to load the shader. So we're just gonna say, let's just say GL unsigned int, right? And we have GL included at the top, so that's good. So we're gonna have an unsigned int for the shader because the way things work in OpenGL, basically it allocates some memory on the GPU and then uses an unsigned int as a handle to that address. And that's how you can refer to your shaders. All right, so we need to create a shader, so I'm just gonna say shader allocate, right? Yeah, we'll just say void for now. Void. And then we'll put that in there. And let's see. Oh. Yes, overwrite it. I always do that, man. Okay, there we go. So now our code is nicely formatted, except we don't have standard C out. So I'm gonna just replace that guy with, wait, standard C out. I'm gonna replace that with printf, like that. And we're gonna do another one. We're gonna replace standard end line. Well, I guess we'll just do this. Replace standard end line with just a closing thingy. All right, but this is still not done. We need to replace this here with a comma, and then %s in here. And let's just do this one more time. Replace that with a comma, %s. Oops. All right, so just do that one too. All right, so basically, I mean, if you know about OpenGL, this is some very basic stuff, but really, we're just creating a couple of unsigned integers here for handles to shaders, and really they should be, technically, they should be GL unsigned ints. So everywhere we see unsigned, I'm just gonna say GL unsigned int, right? But so here, basically what we have is we have this part which actually, you know, compiles the shader. So we have the creation of the shaders right here, right? We're going to create a vertex shader. That's, you kind of have to pass it what type of shader you want to create. And then here, we're going to basically send the source to the GPU, I'm pretty sure, is what this is. Let me verify that. If we just go here and then we do shader source for GL4 docs, returns the concatenation of the source code strings from the shader object specified by the shader. The source code strings for the shader object are the result of a previous call to GL shader source. The strings returned by the function will be null terminated. Okay, well that's interesting. So get shader source returns, oh wow. Oh wait. No, this is the wrong function. GL shader source is the one we want. Sorry. Okay, so GL shader source sets the source code in the shader, which is the unsigned int, right? We're using that as a handle. So the shader is, we're setting the code inside that shader to the source code in the array of strings specified by string, right? So that's that, right? I think that's just about as deep as I'm going to go with that. You can read more if you want. But yeah, then we compile the shader because we just sent it some source code, so we need to actually compile it. And actually, I say. So next up, yeah, this is basically checking for errors. So if there were any errors compiling the shader, then this is where you're going to get them. And it's going to print them out for you, which is very cool. Let me just format this a little bit better. So maybe it's a little easier to read. There we go. All right, so that's our error check. This paragraph right here, that's our error checking. And then we're just basically going to reuse this success variable, which is a technique tried and true, as old as time. This paragraph here, we're doing the same exact thing but for the fragment shader. So notable difference is wherever you saw the word vertex before, now it says fragment. That's just about the only difference. And then here, if I, yeah. So this right here, we're actually linking the program together. So we need to link the vertex shader and the fragment shader together into one program. Kind of like how you link all your C files into one program. It's the same type of concept. And then we just delete the vertex shader and the fragment shader, and we return the program. Shader program. Just like that. So now, yep, everything compiles. That's cool. This is a nice little helper function. We will be able to just, yeah, so here's the thing. It uses this string and this string up here. Eventually we'll be able to load strings from files and actually have like GLSL files, which is really nice later down the road. But for now, we just have these strings here. So basically, let's just actually compile our shaders here. So after we call start, we're gonna do shader alloc, and that's gonna be a GL unsigned int shader equals shader alloc. And what does this take? Nothing. Takes nothing at all. All right, so we're just going to create our shader like that. And let me just, at the end of our program, we're gonna call GL delete program, right? Yep. GL delete program, and I believe we just give it 1 and then the address of the shader. I'm not 100% sure on that, so let me just GL delete program for OpenGL4. Oh, I guess my dad just restarted the router. Okay. All right, I got a little distracted from the Wi-Fi going out there, but okay. So, actually, no. I don't know why I'm trying to tell you that. My Wi-Fi didn't go out. It turns out docsgl went out. So what I did is I went to Khronos.org OpenGL reference pages, right? So I'll link this in the description. I'll just leave this tab open, and yeah, you guys will be able to find this. So basically, delete program. Let me see what the parameters are. Program. Okay, so we literally, it just needs to know the shader. And I think it's not a pointer, right? I don't think it's a pointer. No, it's not. All right, cool. So, yeah, we've created and destroyed our shader. Next, we're going to have to go into vertices. So this is going to be our list of vertices. We're just going to make some very basic mesh here. It's just going to be a... I'm not going to copy any of these comments, but this is basically the code to create a mesh, and I'll walk through it a little bit. But we're just going to do this, get rid of all these comments because I don't need them. It's very basic ass OpenGL stuff. Okay, so the cool thing here is our shader, not our shader, our mesh here is defined as a list of floats, which is really cool. So we've got 3 floats. We've got the left corner, we've got the right corner, and we've got the top corner of the triangle. So that's that. You can kind of like do the math there and figure out that that's what it is. You can kind of visualize these coordinates on a Cartesian plane, or a 3D coordinate system, I guess. even though the z-axes are all 0, so it doesn't really, it's not, it is 3D, but for all intents and purposes, it's not 3D. That's actually how all 2D is handled in OpenGL, because like OpenGL by nature is 3D. So if you want something to be 2D, you just ignore the z-axis, basically. Turns out to be easier that way. But okay, so we're not seeing a triangle. What's going on? Basically, we're not drawing it yet. I haven't called the GL draw vertex array. GL draw arrays, I think, is what it is. But yeah, so we need to Clang format right here because things got a little out of whack. But all right, this is another thing. These are some more OpenGL objects, which means again, wrongfully, they are not GLU ints. They should be, but they weren't. And also, this here should be GL float instead of float. Trying to see if there's anything else here. Yes, this here should be GL float. It's not a huge deal because the odds of GL float being different than your system float are pretty low. But technically it can happen. So yeah. Just for portability, maybe just use GL float and stuff. Anyway, so we're creating a VBO and a VAO. A VAO is a vertex array object, a VBO is a vertex buffer object. They're related. Basically, the buffer object is going to store the actual vertices, and then the array object is going to kind of relate all that data together. So like a mesh can have multiple VBOs, right? It can have one for vertices and one for normals and one for texture coordinates if you want, or it can just have multiple VBOs that are all, they all store different meshes, right? So you can have a VAO that has actually multiple meshes in it and then just transform it as one thing. So that's pretty cool. This is why VBOs are nice, among other reasons that that are just way above my head. So here we go. GL gen vertex arrays, we're basically just creating that vertex array object, and then here we're creating the vertex buffer object. GL bind vertex array, so in OpenGL there's this like concept of binding things. You have to tell OpenGL which vertex array object you're working with or which shader you're working with, and actually I'm gonna do that in my loop here. I'm going to say GL use program to actually set our shader to be active here. And that's kind of like the same thing because you can switch between shaders using that function. Here, yeah, I already explained that. And then bind buffer, just explained that. GL buffer data, basically, this is the actual act of sending the list of vertices. So basically just like this right here, we're just sending all of these floats to the GPU in a memory buffer. And a buffer is just literally just memory. But yeah, it's just, this is the act of sending it from RAM to VRAM. So that's cool. And then here, vertex attrib pointer, we have to actually tell it the kind of like the, what's it called, the how our vertices are ordered. So there's some ways that you can do this. You can have like, you can have a position for each vertice, but you can also have like, say I wanted a normal, like if I wanted these to all be facing toward the camera, quote unquote camera, I could do this. That way they're all facing back like that. That would be an example of why you would need to tell it about the layout. Here our layout is very simple, so there's not really much for me to explain here, but we're just saying that attribute 0 is going to be 3 floats. So that's what this 3 is, and this GL float. We're just saying that each vertex is going to be 3 floats. If we had like a normal coordinate, like I was just saying earlier right here, it would be 6 floats, and you know, obviously we would have to do it for all of them like this. Oops. So we would end up with something like this, except there would be a comma right here, just like that. But we're not doing this, so I'm wasting my time, basically. Oh boy. Ah! No! I'm so bad right now. Okay. Anyway. Let's just do this here. Let's just say... Yeah, so we have 3 floats, right? GL false, I don't actually remember fully what the parameters are here. Oh gosh. There we go. So GL, what was it? Vertex. I don't actually see it in here. Where is it? Where actually is it? What? Vertex attrib pointer. There it is. Goodness. This thing needs a search function for real. Alright, so, yeah. Vertex attrib pointer, size, type, normalized. That's cool. I didn't realize you could do that. So basically you can normalize this to a unit vector. Like, say if this was a normal vector, you could set this to GL true, and then it would normalize it, which is pretty fancy, pretty cool. Okay, so that's that mystery solved. 3 times size of GL float. This is basically the number of bytes that one vertex is. So like size of GL float, if your float is 4 bytes, or yeah, 4 bytes, I think, or 2 bytes? I don't remember. If your float is 2 bytes or 4 bytes or whatever, then it's going to be 3 times that. So that's basically that. And then this is actually the pointer offset, I believe. Yeah, I think this is... Let's look at the pointer. Specifies a offset. Okay, this should have been an offset, but specifies a offset of the first component of the first generic vertex attribute in the array, the data store, the buffer. Okay, so basically, where in the buffer do you want to start? Do you want to start at index 0, or do you want to start at index 5, or whatever? Basically, this doesn't matter. You can just always set it to 0 pretty much for the most part. Here, enable the vertex attrib array after we've set it up here. So this is actually setting it up, and then this is enabling it, telling OpenGL we actually want to use it. And then bind buffer 0. This is actually binding, unbinding the vertex array buffer. It's important to note here, though, you don't want to unbind the vertex buffer object, because the problem with doing that is basically you want it to stay related to the VAO. So if you unbind it, it's actually going to disassociate it from the VAO, and then your mesh won't render, or you'll get some error. Actually, I don't know if you will get an error. You might just be scratching your head for a while. But yeah, this is good because, you know, you should always unbind your vertex array objects, but not your buffer objects. Not until you're ready to get rid of them, because that could get really annoying really fast. And then GL bind vertex array 0. Oh, wait a minute. Bind buffer 0, bind vertex array 0. This doesn't seem right to me. This is a, oh. I lied. I'm talking out my ass. This is allowed. Basically, I think this is actually unbinding the VBO, the thing that I was literally just like, we don't do this ever. Actually, no, it's fine. So, the call to GL vertex attrib pointer registered VBO as the vertex attributes bound vertex buffer object. So after we can safely unbind it. Oh. So the VAO. Okay, that's cool. That's interesting. Apparently you can unbind it. So you can unbind it from OpenGL, but it's still bound to the VAO, I guess. That's cool. Alright, I learned a thing. That's what this is all about, learning. Okay. Next, we're gonna have, let's see, clearing the window, using the program, we're doing this already. Bind vertex array and draw triangles. This is what we need to do, and then swapping buffers and polling events, we don't need to worry about that, because we're already handling that in a separate area, in this process events function, actually. Okay. So if we delete that and then format this code, all right. Theoretically, this should draw a triangle. If it doesn't, I might cry. Let's do this. Oops. Hey, we got a triangle. All right, pretty ugly triangle. That was the Win32 version. Let's try X11. X11, it is not working. So we have a problem somewhere. Interesting concept. Alright, so I figured out what the bug is. It didn't really take that long, and I didn't change any code off camera, really. It's literally just the fact that we're clearing the screen right before we swap buffers. I'm like 99% sure, yeah. So that was it. That was the bug. Cool, thanks. We did a triangle. Thank you for watching. Hope you enjoyed. I hope this was fun. We also fixed a lot of bugs. I'm going to have to do a little bit more research for next time, because next time I want to do input. I kind of said we were going to do that this time, but it's not looking like we're going to do that this time. Let's see. Yeah, we are 44 minutes. That's not terrible. I mean, this doesn't seem like... maybe I'll just stop here. I don't know. Seems fine. This seems like a good, solid bit of progress. Yeah. So I'll see you guys next time. Thank you for watching. We'll do input next time. We'll actually do some kind of, cross-platform keyboard input. We did get the triangle done though, as promised. Alright, cool. See you guys.